Hello and welcome back to a summary of Lecture 7. So far, we're still discussing the properties of pure substances. We talked about the properties for common substances and how we use the tables to get those. We also spoke about gas equations, how if we have an ideal gas and a real gas, and we sort of link those together with the compressibility factor, which is Z in here. We left off the last lecture with the question of how would we get the internal energy and the enthalpy, since the Z doesn't really connect those. In this lecture, we're going to discuss deeper the specific heats and the internal energy and enthalpy and how they're very temperature dependent. We're also going to talk about 3 specific methods on determining these properties for ideal gases. We start off with the first one. It's the most basic. This is also the most accurate one. It's property tables. We have specific property tables from A17 to A25 for ideal gases for the different substances that you'd have in a problem. This is very intuitive. It's just properties from a table. We've been doing this so far. We're going to solve a few problems and you're going to see how this works. The second method is a variable specific heat. In this one, it's more of a mathematical expression, and we're going to talk about where this is derived from in the lecture. After that, essentially what you have is coefficients, and these vary for different ideal gases. You could find all of this in table A2. You'd essentially just plug in these coefficients and you'd solve for your CP and CV. After that, we will talk about constant specific heats in table A2B. In this one, we sort of assume a linear approximation for your temperatures. So technically, your CP average will just be your average between 2 different temperatures, and so is CV for your internal energy. We will also solve a few problems on this and discuss sort of the rationale behind the average CPs. With that being said, this concludes our gas equations, and we sort of introduce incompressible substances. In short, incompressible substances are just substances with constant density. We have a new set of equations which we'll dive deeper in the lecture as well, and we will sort of see how we could use those. In the last part of this lecture, we were sort of introduced the first law of thermodynamics. We've been talking about this a while, so you sort of know how it works. So the total change of a system is just the total energy that's entering minus the total energy that's leaving, and we'll talk about this in more detail. After which, this is a very general plan on how the first law of thermodynamics is going to be structured in this course. We're going to first talk about closed systems, where there's no mass transfer in the system, and then we'll open it up to an open system with mass transfer, and we'll discuss those in future chapters.